Everyone, welcome back to the Comptia Network Plus course, Hypervisor. The host is responsible for allocating compute resources to each of the VMs as specified by the configuration. The software that manages all this is called the hypervisor. Based on the parameters set by the administrator, the hypervisor may take various actions to maintain the performance of each guest as specified by the administrator. This may include the following actions: turning off a VM not in use, taking CPU resources away from one VM to allocate them to another, turning on additional VMs when required to provide fault tolerance. The exact nature of the relationship between the hypervisor, the host operating system, and the guest operating system depends on the type of hypervisor in use. There are two types of hypervisors in use today. Let's review both of these. Type 1. A Type 1 hypervisor or native bare metal runs directly on the host hardware to control the hardware and to manage guest operating systems. A guest operating system runs on another level above the hypervisor. Examples of these are VMware vSphere and Microsoft Hyper-V. A Type 2 hypervisor runs within a conventional operating system with the hypervisor layer as a distinct second software level. The guest operating system runs at the third level above the hardware. VMware Workstation and VirtualBox exemplify Type 2 hypervisors. A comparison of the two approaches as shown in figure 20.12. Virtual servers. Virtual servers can perform all the same functions as physical servers but can enjoy some significant advantages. By clustering a virtual server with other virtual servers located on different hosts, you can achieve fault tolerance in the case of a host failure. Increased performance can also be derived from this approach. The virtualization software can allow you to allocate CPU and memory resources to the virtual machines VMs dynamically as needed to ensure that the maximum amount of computing power is available to any single VM at any moment, while not wasting any of the power on an idle VM. In fact, in situations where VMs have been clustered, they may have been suspended or powered down in times of lower demand in the cluster. Virtual switches. Virtual switches are software versions of a layer 2 switch that can be used to create virtual networks. They can be used for the same purpose as physical switches. VLANs can be created, virtual servers can be connected to the switches, and the virtual network can be managed all while residing on the same physical box. These switches can also span multiple hosts. The physical machines that house multiple virtual servers, desktops, and switches are called hosts. Distributed virtual machines are those switches that span multiple hosts, and they are what link together the VMs that are located on different hosts yet are members of the same cluster. Virtual versus physical NICs. Figure 20.13 shows the relationship between a physical server and the virtual servers and virtual switches, that is hosts. The virtual switches called virtual machines VMs have virtual networking cards, VNICs, that connect to the virtual switch. Keep in mind that all of these components are software running on the same physical server. Then the virtual switch makes a software connection to the physical NIC on the physical host, which makes a physical connection to the physical switch in the network. It is interesting to note and important to be aware to the fact that IP addresses of the physical NIC in figure 20.13 will actually be transmitting packets from multiple MAC addresses, since each of these servers will have a unique virtual MAC address. So here you can see in figure 20.13 a physical server. So virtual machine, virtual machine, virtual machine, virtual switch, and here's your physical switch. Virtual routers. In virtualized environments, virtual routers are typically implemented as specialized software. They consist of individual routing and forwarding tables, each of which would be considered a virtual router. Virtual firewall. Virtual firewalls are also virtual firewalls are also implemented as software in the virtualized environment like their physical counterparts. They can be used to restrict traffic between virtual subnets created by virtual routers. Software-defined networking. Software-defined networking, SDN, is an approach to computer networking that allows network administrators to manage network services through abstraction of lower-level functionality. SDN architectures decouple network control and forwarding functions, enabling network control to become directly programmable and the underlying infrastructure to be abstracted from applications and network services. Virtual desktops. Using operating system images for desktop computers is not a new concept. Delivering these desktop images to users from a virtual environment where they start their computer this allows for the user desktop to require less computing power, especially if the applications are also delivered virtually and those applications are running in a VM in the cloud rather than in the local desktop, eating up local resources. A benefit of using virtual desktops is the ability to maintain a consistent user environment, same desktop applications, which can enhance user support. Thin computing takes this a step further. In this case, all the computing is taking place on the server. A thin client is simply displaying the output from the operating system running in the cloud, and the keyboard is used to interact with that operating system in the cloud. Does this sound like terminals with a GUI to anyone yet? Back to the Future indeed. These thin clients need very little processing power for this job. Virtual PBX. Virtual PBX is an example of what is called software as a service. A hosting company manages the entire phone system for the company, freeing the organization from the need to purchase and manage the physical equipment that would be required otherwise to provide the same level of service to the outside world. The company appears to have a professional phone system while everything is actually being routed through the hosting company's system. Network as a service. Now that you know what SaaS is, you can probably guess what NaaS is. You guessed it. A network hosted and managed by a third party on behalf of the company. For many enterprises, it makes more sense to outsource the management of the network to a third party when it is not cost effective to maintain a networking staff. Storage area networks. Storage area networks, SANs, comprise high capacity storage devices that are connected by a high speed private network separated from the LAN using a storage specific switch. The storage information architecture addresses the collection of data, management of data, and use of data. In this section, we'll take a look at the protocols that can be used to access the data and the client systems that can use those various protocols. We'll also look at an alternative to SAN, network attached storage, NAS. iSCSI, Internet Small Computer System Interface, is an IP-based networking storage standard method of encapsulating SCSI commands which are used with storage area networks within IP packets. This allows the use of the same network for storage and is used or the balance of the network. A comparison of a regular SAN that uses the fiber channel protocol, and one using iSCSI is shown in figure 20.14. I'll talk more about fiber channel in a bit. InfiniBand. InfiniBand is a communication standard that provides high performance with and low latency. It is utilized as a direct or switched interconnect between servers and storage systems, as well as an interconnect between storage systems. It uses a switched fabric topology. The adapters can exchange information on QoS, which is quality of standard. Fiber channel or SRFC is a high-speed network topology commonly running at 2, 4, 8 and 16 gigabit per second rates, primarily used to connect computer data storage. It operates on an optical network that is not compatible with regular IP-based data network. As you can see in figure 20.14, this protocol runs on a private network that connects two servers to the storage network. Fiber channel over Ethernet FCOE, on the other hand, encapsulates fiber channel traffic within Ethernet frames, much like iSCSI encapsulate SCSI commands in IP packets. However, unlike iSCSI, it does not use IP at all. It does not allow this traffic on the IP network. Jumbo frames. Jumbo frames are Ethernet frames with more than 1,500 bytes of payload. Jumbo frames with more than 9,000 byte payloads have the potential to reduce overhead and CPU cycles. In high-speed networks, such as those typically used in a SAN, it may be advisable to enable jumbo frames to improve performance. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.